Hi, everyone. This is the second installment of a podcast series from Scality. We are the vendors of software-defined storage products that are used by corporations and governments and service providers worldwide. I'm fortunate enough to be joined by my cohort here, which is Giorgio. Giorgio, you're one of the founders of Scality. Can you say hello?
Hi, Paul. Hi, everybody.
Giorgio has been the CTO of the company since the inception, knows everything top to bottom about our solutions and lots about the industry. I am fortunate enough to be the CMO, the Chief Marketing Officer, and we're going to undertake another topic here that we hope is of interest to you.
So
Uh,
before we move to the next slide, that topic is going to be a little bit spicy because you're going to comment on performance numbers from the competition or from other vendors.
yeah, that's right. So we have obviously seen this industry grow and morph over the last dozen years and longer. Object storage certainly didn't start being known as a performance play, right? And this is where we want to kind of zoom in is object storage performance. Those of you that know the industry know this really started as an archival storage method, a way to store millions, billions, and even more unstructured data items as objects in the storage system. Very effective at that. Object storage is very scalable. People didn't think about this as being high performance before, but that changed. I would say it changed about 5 years ago, right? We started seeing more use in analytics, like with Splunk and Elastic. And then we started embracing all flash. And that certainly started making a big leap. You and I, we've been observing the news in the industry, and I think we're starting to see a lot of big claims about huge performance numbers, especially from vendors that are trying to pump up newer systems, I would say, that are just appearing on the
Yeah.
market. So
That,
maybe we can talk about one of those.
yeah. And before we jump to that, there's something that today we mostly all use the same hardware. We're running on Intel or AMD CPUs using drives from two manufacturers and flash drives that have the same technology, TLC or QLC, but mainly the same tech. So the difference is in the software, but we're all working hard to optimize our software. So then the architecture becomes a big differentiator. So when you see numbers, you have to think, what is the architecture? What are the choices that have been made for me in these numbers? And what does it mean for our use case or my use case? And these are kind of things you need to ask yourself when you look at these numbers.
Yeah, that's a very relevant comment. Again, doing this in software means that we give the user the choice of what
Mhm.
server to run on, but like you said, they fit the mold of standard or commodity server, right? Intel AMD. And for many years, we'd of course leveraged capacity optimized storage media, meaning big density hard disks. The industry ourselves, we're now leveraging all flash more and more.
Yep.
All right. Well, let's do the interesting part then and kind of comment on what we're seeing in the news. We did see some recent performance claims from a vendor that we all know, HPE. They have a new object store in the market as of about a year ago. It's called the X10000 or the X10K. In the last few weeks, we did see them put out some claims about very high performance for backup. I've seen numbers like 300 terabytes per hour per node, 1.2 petabytes per hour for a 4-node cluster. Can you kind of comment on how we should understand these numbers, Giorgio?
So the way that I understood it, it's the write performance, 1 to 2 petabyte per hour.
Yeah, you're backing up. That's right.
Yeah. So when I see backup, I'm asking about the restore performance. I don't know you, but I'm more
Yeah,
I'm more interested in the restore performance. But
that's right.
let's zoom on the write performance. It's pretty clear from the document that this is adding a write cache called an accelerator node in front of the object store, which is a well-known technique in storage. We can call it a gateway, right? We've looked at gateway before. It boosts performance, but it comes at a cost. There's some drawbacks. So maybe we can talk about that if you go to the next slide.
Yeah, absolutely. Maybe before we talk about it, you're absolutely right. When I think backup in the day of ransomware today, it's all about how quick you can get the
Yeah.
data back, right? How quick you can restore. Here, indeed, they're talking about this performance number for writing the data, writing the backups. Yeah, but you were mentioning some of these items here below.
So when you have something in front of your object store, then you lose a lot of the object store benefits. One of them is, from what I understood from everything I read so far about this, is you have to go for a gateway to read the data. You cannot go to the object store anymore. So that means everything is constrained to that layer. That means if you lose that layer, no
Mm,
matter how durable your object store is, you've lost your data effectively.
got it.
Because it keeps tracks of metadata, it does deduplication too. So whatever is in the object store is unreadable without the layer, right?
Ah.
So you have to be, so make sure when you look at your durability, don't only look at your object store durability, which is going to be overshot. You have
Mhm.
to consider the accelerator layer durability as well.
Yeah,
Because
you're
now it's
reminding me
key.
of all the
Yeah.
trade-offs of data.
We've done that before, right?
Right.
So it's a deduplication of that layer. Now, what happens if the storage in the back is not fast enough, right?
Mhm.
So you start accumulating data into this accelerator node, which is a low capacity compared to the object store. So I don't know how much there's going to be, but maybe there's 1 hour of backup or 2 hours of backup capacity. If you start to go way too fast for way too long, then you end up having to stop traffic, because if the accelerator cache is full,
You th-
or you can go directly to the object store, and now you throttle the traffic down to what the object store could do, but,
Right.
but by definition is already overloaded. So you're going to go directly to something that's already overloaded if your cache
Mhm.
is full. So it's not a good idea.
Right.
And read performance is going to be read performance of the tier 2, because the chance that the data is still in tier 1 is very low. If a year from now you want to restore, the data is not going to be in the cache.
I see. I
So
see.
now, what is your read performance is going to be the one of the layer below. So make sure it's good enough for your restore need.
I understand. Yeah. So this is really, it's trying to separate the jobs, right? You have the storage system and you have the dedupe happening on this accelerator node. It also makes me think on the restore side, it'll have to do work obviously to reassemble everything. So there's going to be,
There's that too. So now the restore is more costly or more complex, because it
Mhm.
needs to first go to the accelerator node, get all the data that it needs from the object store in the back, which could be multiple data, especially if the dedupe. You may have to restore an old block and then apply your delta on it.
Yeah.
So
Yeah.
it's a lot more IOPS. Compute that and then serve the data.
Okay. Makes sense. Yeah. I think this topic is fascinating. There's obviously a lot to talk about. Vendors in the storage world obviously put out benchmarks, lab tests. We ourselves deal a lot with real world, huge deployments, and we have some kind of real world production numbers. I think that can be a great topic for us.
Yeah. We're going to look at this, and we're going to do more of this analysis as a user. So
Mhm.
when I see this number, if I was a buyer, or technical decision maker, I would say, nice, that's a very good number for white performance. Now I have all these 10 more questions,
Yeah.
because that's only one part of the picture.
Yeah. Yeah. I understand. It really also has to adapt to the user's use case, right? Is it always going to be applicable, these numbers?
Yep.
Okay. Very enlightening. And I think it's a fascinating topic for us to carry forward. I'm going to hint a little bit about that. We will plan some more discussions on performance, whether it's lab tests and benchmarks or real world. I wanted to leave the audience here with a quick link or two. We do have an object storage performance blog related to AI data pipelines. There's a link to that. And then we are also a vendor of an all-flash object store called Ring XP. So there's a pointer for those that might be interested in taking a look at a specific solution. So I think with that, thank you very much, everybody. And thanks, Giorgio. And we'll see you on the next one.
Thanks, Paul. Thanks, everybody.
Thanks.